It's time to export the knowledge. In this video, we're going to be talking about the remainder theorem and the factor theorem and how we use them to factor polynomials. So in front of me here, I have a cubic, x cubed plus 4x squared plus 4x plus 3. And I'm going to divide this polynomial by x minus 1. So let's divide x minus 1. Right, pay attention to the remainder 12 part. Right, I'm going to now sub in positive 1. Positive 1. Notice that I'm using the null factor law on this here. Positive 1. So P of positive 1 equals Q plus 4 squared plus 1 plus 3. This will just become 1, that'll become 4, that'll become 4, that'll become 3. I can add those, so now I have 3 4s, which is 12. That's the result that we got before, the remainder. So by using the null factor law on the linear factor and subbing that value in, I get the remainder. So this is an important result. This is known as the remainder theorem, and we can generalize it. So let's rewrite the polynomial. P of x is equal to x minus some value alpha, the Greek letter, times the quotient plus the remainder. So if I sub in alpha, P of alpha, I'll get alpha minus alpha, which is 0. 0 times this quotient is going to be 0. I'm going to have 0 plus my remainder, whatever the remainder is. And we can take this a step further as well by introducing a coefficient in front here. This is now beta x minus alpha. So now instead of subbing in alpha, I will sub in alpha divided by beta. And we can see that we're just null factor lawing this linear factor here. And when we sub that in, right, we times it by beta, we're going to have alpha. Alpha minus alpha is 0. 0 times the quotient is going to be 0. We're going to left with 0 plus the remainder. So that's the remainder theorem. So if we wanted to factor this polynomial, we would need to find a value for alpha and beta such that this remainder that we're left with is 0. So that way, just have some expression, the linear factor that we found, times the quotient, and we'll have no remainder, so this part will be irrelevant. And that would mean that when we sub it back in, we will be left with 0. So let's think about how we can do that. So firstly, for this particular polynomial, notice that the coefficient of the leading term is 1. Right? Now this is important. If it's 1, you don't have to worry about beta. Right? End of discussion. Don't worry about beta. Just focus on alpha. Right? Because beta is either going to be 1 or negative 1, but you can represent that in alpha anyway, so there's no real point. So just search for values for alpha. So how do we find values for alpha? We look at the constant term. So in this case, we have a positive 3. So what we do with this positive 3 is we find factors. Not just any factors, we want prime factors. So for 3, it will be positive 1 and 3. and we can also have -1 and -3, right? So to simplify this, because we can have both positive and negative versions of each other, we can just write the factors are positive plus -1 and plus -3, right? And then we just have to sub in those possible values. So we have 4 possible values and we just sub them in. Already looked at alpha being +1 and we saw that that was not the case. So let's take a look at 3 for the value. So we can sub in 3, work it out. I already know that 3 is not going to be 3, isn't it? -1, we can sub it in just the same. I know -1 is not going to be it. -3. Let's see if I'm right. So how do I know that those values aren't there? Aren't factors? It's because I made the question. So I already know the answer. So let's sub in -3. P of -3. And let's see what happens. So we'll have -3 cubed plus 4 lots of -3 squared plus 4 lots of -3 plus 3. Alright, now here the negative will cancel, right? So we're left with 4 times 9 times 9 is 36. Here have a negative, -12. Have the 3. Now what happens here? Have an odd power. Does it stay negative or does it become positive? The answer is negative. Why? -3 times -3 times -3. Right? These two will become positive. We have an extra negative. -27. Add them together. These two will become negative, will become positive 24. The -27 and the 3 will become -24. And yes, they do cancel. So now that I subbed in this, right, I can now confirm that x minus -3 or x plus 3 is a factor, right? Let's make it a plus. So x plus 3 is a factor of this polynomial. So I can now divide this polynomial by x plus 3. Now I can do it the long way, or I can do it the better, faster way, right? Which way am I doing it? I've already showed you the long way. I'm not doing the long way again. That takes too much time. I'm going to do the short way. If you don't know what the short way is, then I have a video on it. Go watch it. 1, 4, 3. Drop the 1, minus 3, 1, minus 3, 1, minus 3, 0. So now, this polynomial P of x equals x plus 3 lots of x squared plus x plus 1, right? And if we could factor this quadratic even more, would, but in this case we can't, so we leave it as is and we say this is factorized. That was when the coefficient or the leading term was 1. So what happens if the coefficient is something other than 1? Well, we have a different theorem for that. It's called the rational root theorem. So let's take a look at this polynomial, 2x cubed minus x squared minus x minus 3. Now, previously, we looked for prime factors of the constant term. Now, we still need to do that, so let's just list them. Plus minus 1 and plus minus 3, just as we discovered beforehand. If we sub in all these values into here, we're not going to get, we sub them in, we're not going to get 0, which is what we want to factorize. So, we need to think about the leading term now. Well, so that is going to be our beta value. Remember how we just sort of disregarded beta? Now we need it. So because these are integers, and when we sub them all in, none of them actually give us 0. We can ask, is there a rational solution, right? And that's where the rational root theorem comes in. So it says if alpha and beta have a highest common factor of 1, otherwise they're relatively prime, meaning 3 and 15 are not relatively prime, but 3 and 5 are, 6 and 7 are, right? Notice that 6 isn't prime, but it is relatively prime to 7. 6 is 2 times 3, and 7 is 7, right? They don't share any prime factors, so they are relatively prime. So assuming that beta x plus alpha is a factor of this polynomial, right? Beta x plus alpha is a factor here, then beta has to divide into 2, and alpha has to divide into minus 3. Now, the only value that we need to think about for beta is 2, right? Why is that? It's going to be 2, going to have 2x times something like x squared, right, to make the x cubed. Can't have a negative 2x here, right? Unless we make the whole thing negative. And if we do that, we might as well just factor it out anyway. So we can only consider 2 for beta. And then we just have to combine it with alpha. So if this is a factor here, p of negative alpha over beta has to equal 0. So we just have to find our alpha value now that we know that beta is 2. So we can try alpha being 1 and alpha being 3, and because I already know the answer, I'm just going to check it once. So I know that p of 3 over 2 is going to be answer. So we can sub this in. We're going to have 2 lots of, I'm going to expand it now, 27 over 8 minus 9 over 4 minus 3 over 2 minus 3. And if you expanded all of this would be 27 over 4, 27 minus 9, going to be 18. 18 over 4. You can half that, that's now 9 over 2 minus 3. Get 9 minus 3 is 6. 6 divided by 2 is 3. 3 minus 3 is 0. So yes, this does indeed equal 0. Now I did that mentally, but you can show down you're working out as much as you need to. So now that this is a factor, we can divide this polynomial to find out the other possible factors if we to do that quickly. We have 2 is 3, 2, 3, 2, 3, 2, 3, remain 0. Be left with 2x minus 3 lots of x squared plus x plus 1. Now if we wanted to see if we could factor this down any further, we can take this quadratic and use the discriminant that we've talked about in previous videos to check to see if there's any other solutions. Now there are some special cases. So when we did quadratics, there was this thing, the difference of 2 squares. Well, Cubes have the exact same thing. There's the difference of two cubes. And this is equal to a minus b lots of a squared plus ab plus b squared. And similarly, we can have the sum of two cubes this time, because this is an odd power. We can sub b for negative b, and we will get a negative b, which is plus b, times a squared. Now we have a times negative b, negative ab, and then this will be negative b squared, which is just positive b. So now we have an addition of two cubes. And if you really wanted to, you can actually divide these two by these factors here to prove that this is indeed the case. So a nifty way to remember this, rather than writing this in your notes, is SOAP. SOAP, right? Let me just walk you through it. You see the sign here? It's all to do with the signs. They're the same. They're opposite. This is always positive here, right? Same, opposite, always positive. SOAP. Okay, that might be a nifty trick for you to remember the different signs in between here. So let's actually use it. A cubed minus b cubed is equal to same a minus b times a squared, opposite, so it's positive ab, and it's always positive, SOAP, right? So that can help you just make sure that you've got the right signs. So that's it for this video. If you have any questions, feel free to comment down below or contact me on social media, and I will see you in the next video.